So till now what we have seen, seen basic remainder theorem, right? Then we have seen some interesting patterns which is related to basic remainder theorem. Then we have discussed about divisibility completely, right? Then we have discussed about divisibility. Then we have seen last digit and last two digits, right? So this is what we have completed in the previous 5 videos. Now what we are going to do is we are going to look at some complicated questions, little higher level questions, where you need to factorize the numerator. That is what we have seen till now. But when you look at the denominator, there is no such pattern or anything, okay? Just like a random question like 11 raised to 87 divided by 7. So this kinds of question, what is the remainder, we are going to solve now by using the concept of Fermat theorem, okay? You don't want to know the theorem, you don't want to study the theorem, proof and all is not required. But anyway, I'll also discuss about the proof just for the sake of discussing. And after that we will move on to solve the question, okay? So 11 raised to 87 by 7. Now if you look at this, these two are coprime numbers. Now what do you mean by coprime numbers? Coprime numbers means these two numbers, that is 11 and 7, they don't have any common factors other than 1. What does it mean? In another way I can say that their HCF is 1. That means no other common factor except 1. Okay, so this kinds of question we can take it as a pattern. Now when you look at this, you won't understand a pattern, so we are going to take it as a pattern. What is that? These two are coprime numbers. Then I'll give you a method. Okay, now after this we will discuss about some complex question when it is 77, where you need to factorize the numerator and denominator. Okay, then these two are not coprimes. Okay, these are not coprimes. Now there is a common factor, right? 11, so they are not coprimes. Then what method you need to use, I'll discuss in the next video. There I'll be discussing about Chinese remainder theorem. So here we are concerned about factorizing the numerator, okay, when these two are coprimes. Then in the next video I'll be talking about you may factorize the numerator and the denominator also. When it is 77, you will have to write it as 11 into 7 and then we will solve. Okay, that is a bit more advanced method. Okay, so anyway, this Fermat theorem questions are your round 1 question, must attempt. The Chinese remainder is going to be your round 2 question, where you need to factorize the numerator and denominator. That I'll be discussing in the next video. So let's start off with Fermat theorem. So the questions will be like this. You get a random question, a raised to x divided by some number n. What is the remainder? Okay. Now the pattern here is a and n are coprime numbers. Then this method is applicable. Method I am going to discuss. I hope you understood what you mean by coprime numbers. Both of them don't have any common factors. See, if I write 3 raised to 9 divided by 9, then this method is not applicable because these two are not coprimes. They have a common factor which is 3. Okay, but if I write 8 by 9, these two are coprime numbers. Okay, so 8 by 9, 8 raised to anything, 13 or something, whatever it is, not a problem. I am looking for these two. These two are coprime numbers. Now how will you know whether it is coprime numbers or not? That is what we are going to discuss. Okay, so but logic is actually if you take two consecutive natural numbers, 7, 8, these two are coprime numbers. But you may not get like this, right? You may get 107 like this. So you need to know whether they are coprime or not. So I'll anyway discuss the method, not a problem. Now see, two consecutive natural numbers are coprime numbers. You take two consecutive odd numbers like 7, 9, they are coprime numbers, or 11, 13, they are coprime numbers, or 13, 15, they are coprime numbers. Two consecutive odd numbers are also coprime numbers. Now two prime numbers if you take, they also are coprime numbers. 3 and 5 if you take, or 3, 11 if you take, they are coprime numbers, because anyway prime numbers have exactly two factors. So this number is having 1 and 3, this number is having 1 and 11. So only one common factor you can see, that is 1. So anyway it has to be a coprime number, right? So two prime numbers are coprime numbers. Two consecutive natural numbers are coprime numbers. Two odd numbers are coprime numbers. So coprime number is a different concept that also is required for you, okay, in number system. So you may get questions based on coprime numbers itself, but here I am just discussing coprime as a part of this theorem or the method. So I'm not spending too much time on it. Let's move on to the method. Now let's take a question. 11 raised to 87 divided by 7, or you take 13 raised to 87 divided by 7. So here only thing is these two are co-primes. Okay, that's the condition that you need to satisfy. So let's take 13 raised to 87 divided by 7. You need to find the remainder. This is the question, right? So now let's go for a quick recap of what we have done earlier. If you were getting questions like 2 raised to 32 divided by 15, what you do? You will rearrange it, right, in such a way that you will get minus 1 or plus 1 as the remainder, right? So how will you get that? 2 raised to 4 divided by 15, you know you will get 1 as the remainder, then 8. Then you will get the answer, right? Same is the method you are going to use here also. Same is the method, that means you are going to factorize the numerator. But how will you factorize? See, you need to factorize the numerator here also in such a way that when you divide with the denominator, you should get 1 as the remainder. Then it is going to be very easy. I hope you understood. You should get 1 as the remainder. Now, how you do that? That is the difficult part, right? Now, in this case, it is actually easy. If question is this, it is actually easy because 13 by 7, what is the remainder? Minus 1 is the remainder. So, actual answer will be 13 by 7, 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 87 times. So, 87 minus 1 raised to odd will give you minus 1 as the remainder, which will give you actually 6, right? 6 is the remainder in this case. Because these two are the numbers. I hope you understood. That is easy to get minus 1 as the remainder. Okay. But what if 11 by 7? Then you won't get minus 1, right? So then it is difficult. So let's discuss about this. Then we will move on to 11 by 7. Okay. Now if this is not the method, if not 13 by 7 minus 1, is there any other way to get plus 1 as the remainder? Then it is going to be even more easier. Is there any other way to get plus 1 as the remainder? That's what we are looking for. Okay. Yes, there is a way. There is a concept. That's what Fermat theorem. And as per that, if you have a number x, and another number, let's take it as n, these two are co-primes, and then this E I call as Ulas number. So two concepts I am discussing here is Fermat and Ulas number. Okay, Ulas number. It's not important for you to know all these things, but to solve the question it is very useful. Okay, so just give me 5 minutes, and after that you can forget about all these things. The solving the question is very easy. You will take only 30 seconds to solve the question. Understanding may take some time, so give me some time for make you understand this method. After that you can solve any questions, any difficult questions. So 5 minutes you need to give me, okay, so that you will understand it in a much better way. Okay, and this 5 minutes is going to be little difficult. If you can concentrate, it's fine. So this number is called as Ulas number. And what is that number? I tell you, you have a denominator n here. That means in this case you have a denominator 7. So what is E? E is actually related to this number. How it is related is actually number of co-primes less than that number. Okay, so the number of co-primes less than that number means the numbers which are co-prime with that number, how many numbers are there which is less than that number. So you have 7 now, right? So what are the numbers which are co-prime with 7? 1 is co-prime with 7, so 1 and 7 are co-primes. 2, 7 co-primes. 3, 7 they are co-primes. 4, 7 they are co-primes. 5, 7 they are co-primes. 6, 7 they are co-primes. Right? So how many are there? 6 numbers are there which are co-prime with 7 less than 7. Okay, so here this E, if this number is 7, E is actually 6. What does that 6 means? The number of numbers which are co-prime with 7 and less than 7. So if 7 is here, number of numbers co-prime with 7 and less than 7. So 6 numbers are there. I tell you how to find out this answer very faster. You don't want to solve it like this. Now, if I ask you, denominator let's suppose was 9. So what is E of 9? Euler's number of 9. The logic is number of numbers which are co-prime with 9 but less than 9. Okay, 9 and 11 are also co-prime, but that we don't take. Less than 9, how many numbers are co-prime with 9? That's what we are going to check. Okay, so if you see 1 and 9 are co-primes, 2 and 9 are co-primes, no common factor. 3 and 9, they are not co-primes. That's important. 4 and 9 co-primes, 5 and 9 co-primes, 6 and 9, they are not co-primes. They have a common multiple, that is 3. 7 and 9, they are co-primes. 8 and 9, they are co-primes. So what is Euler's number? 1, 2, 3, 4, 5, 6. Euler's number of 9 is also 6. So what do you mean by Euler's number? Number of non-multiples of prime factors. So here multiples are 3 and 9. So we are actually looking for number of non-multiples of prime factors of 9. Okay, so number of non-multiples of prime factors. How many are there? 6 are there. I tell you how to find it out. You don't want to write all these things. Okay, just to make you understand the concept of Euler's number, I am telling this. So I hope you understood the concept of Euler's number. Okay, this is a concept. You have a numerator x, you have a denominator n, and power is Euler's number. Okay, so these two are coprimes. Then in this case remainder will be 1 always. This is what you need to keep in mind. Remainder will be 1. So you have two coprime numbers, and what is the denominator? N is the denominator, and if E is the Euler's number of denominator, the remainder will be 1. So we have just now saw the Euler's number of 7, right? So let's write the denominator 7 to make you understand. Euler's number of 7 we saw 6, right? So let's fix the power as 6. So we fixed this, we fixed this. Now you write any number which is coprime with 7, you get remainder 1. So what are the numbers which coprime with 7, less than 7? You can, when you write here, you can write more than 7 also. But when you write the Euler's number, you should take number of coprimes less than 7. Just to make you understand the concept, to solve the question, all those things are not required. I am solving this question now conceptually. After that, you will solve by using shortcuts. Then it is 30-second answer. Here just to understand. Okay. So, and this is cat level. So tell me one number which is coprime with 7. If I write that number here, you will get remainder 1. That is the idea. So I fixed denominator 7. I know the Euler's number of 7 is 6. Okay. So I fixed that as the power. Then I am leaving the space. What is the condition? These two should be coprimes. So tell me any coprime number which is now tell me any number which is coprime with 7, you will get remainder 1. So you write 1 here. What is the remainder? You will get remainder 1. You write 2 here. What is the remainder? You get remainder 1. You get 3 here. What will be the remainder? You will get remainder 1. You get 4 here. What you will get as a remainder? Remainder will be 1. Why? Because these two are coprimes. And what is this relation? 6 is the Euler's number of 7. What do you mean by Euler's number of 7? Number of non-multiples of prime factors, or number of numbers which are coprime with 7 which is less than 7. So 1, 2, 3, 4, 5, 6. So 6 are there. That's why Euler's number 6. I tell you how to find it. It is very easy. It is actually n into 1 minus 1 by 7. Okay. So how to find the Euler's number of 7? It's actually, what are the factors of 7? 7 you can factorize as 1 into 7, right? So actually your answer is 7 into 1 minus 1 by 7. So 7 into 6 by 7. So 6 is your answer. I tell you why it is. It is very easy. So I tell you why, but this is the step. This is a method you will find the Euler's number of 7. Now just before you found the Euler's number of 9 also, right? So you got it as 6 because 3 and 6 are factors, common multiples. You avoid that, you got the Euler's number of 9 as 6. So you can fix the denominator 9. Euler's number of 9 you can fix as the power. Then if you write here any number, I'm telling any number which is coprime with 9, you will get remainder 1. So obviously 1 by 9 will get remainder 1, right? 2, that will also give you remainder 1. What is 2 raised to 6? 64. 64 by 9, 1 is the remainder. Now 3, you can't use 3, but you can use 4. 4 raised to 6 by 9 will give you remainder 1. 5 raised to 6 by 9 will also give you remainder 1. Can you write 6? No, because these two are not coprimes. 7 if you write, remainder 1. 8 if you write, remainder 1. Now the question is, can I write more than 9? Obviously you can write more than 9. That condition is applicable only when finding Euler's number, less than 9. Now I can write 10, still you get remainder 1. 11, you get remainder 1. 12, you can't get remainder 1 because 12 and 9 common multiple 3 is there. 13, you can get remainder 1. 14, you can get remainder 1. 15, you can't get because common multiple 3. 16, you can get remainder 1. 17, obviously you can get remainder 1. 18, if you write, you can't get because they are not coprimes. 19, you will get remainder 1. 20, you will get remainder 1. 21, you won't get. Now, basically, you can write any number here which is not a multiple of 3. You will get remainder 1. That's what Fermat theorem. Now, how you are going to use it is what I need to discuss now. I hope all of you understood this. Okay, this is very interesting. Now let me tell you how you find the Euler's number. Then it is going to be very easy. Okay, so, or before that, let me answer the question that we have discussed. 13 by 7 raised to what was our this raised to 87 was our power, right? Now how will you answer? We know these two are coprimes, right? And we know the Euler's number of 7. So if it was 13 by 7 raised to 6, what is your answer? Remainder is 1. Why? Because these two are coprimes, and what is 6? 6 is the Euler's number of 7. And that is what our Fermat theorem, right? X raised to e divided by n, remainder will be 1. These two are coprimes, and e is the Euler's number of n. So that condition is satisfied here. So this is what you need to use to factorize the numerator now. So how will you factorize the numerator? You factorize into power of 6. So if you can write 13 as 13 raised to 6 divided by 7, you get remainder 1. Another 13 by 6 by 7 remainder 1. Another 13 by 6 by 7 remainder 1. Another 13 by 6 by 7 remainder 1. So then you will apply basic remainder theorem 1 into 1 into 1 into. See how much is left out. Okay, let's see. If you write it as 13 raised to 6, how many times you can write it like that? Up to 84, right? Up to 84 you can write. That means if up to 14. So 14 such groups you can make. That means up to 84 I can cover. What is the balance? 13 raised to 3. So 13 raised to 3 by 7. Now my answer depends on this only. The reason is this completely will become 1. 13 raised to 6 by 7 is 1. Similarly 14 such groups when you multiply all become 1. Now you can find the answer for this now easily, right? Because this is 13 into 13 divided by 7. You can find the individual reminders easily. Either you can write it as minus 1 into minus 1 into minus 1. You will get minus 1. Which you can convert by adding 7. You get 6. Or you can write the remainder directly. 13 by 7, you get 6, right? So 6 into 6, that is 216, which is greater than 7. So divide by 7 again, you get 6, because 210 is a multiple of 7. 3 into 7 is 21. So 30 into 7 is 210. So 6 is the remainder. So that's what 6. Now, by using what we know already, you can get the answer, right? This only for this question, 13 by 7 raised to 87. We know 13 by 7 you get remainder minus 1. So minus 1 raised to 87, you get minus 1. You can write it as 6. You don't want Euler's number and all. But what if it was 11 by 7 raised to 87? Then you will be in trouble. So 11 by 7 raised to 87. How will you do? What is the logic? 11 and 7 are coprimes. So if instead of 87, if the power was 6, what is 6? Euler's number of 7. That will be 1. 11 raised to 6 by 7 will be 1. So how will you write like this? I can write it as 11 raised to 6 divided by 7, right? 11 raised to 6 into 14. So 14 such groups, all will give you remainder 1. When you multiply, still you get remainder 1. Into rest of the 87, I'll write it as 11 raised to 3 by 7. So your remainder will depend on this. This is not important. Now how will you solve? You can write it as 11 into 11 into 11 by 7. Now by using basic remainder theorem, find the individual remainder if you want. I give you the shortcut for this also. See, we are even now also we are discussing the concept. I am not moved to the shortcut. Shortcut means you'll get the answer in 30 seconds. You don't want to spend this much time. All these are direct. I'll give you the method. Okay. But just understand this. Then you will not forget it. That is the idea. So 11 by 7, what is the remainder? All of you know that is 4. And then 4. So 4 into 4 into 4, you get 64. Divide by 7 again. What is the answer? 63 is a multiple of 7. 9 into 7. So 1 is your remainder. So that's it. As simple as that. Okay. But it is going to be even more simpler when I discuss the shortcut. Okay. Or how you find the Euler's number faster. And based on that, how you're going to solve it. Okay. It's going to be very easy. So everything depends on the Euler's number. Okay, so let's understand what is Euler's number, how to find the Euler's number faster. There is a formula and it is easy to remember, not a big problem. Okay, the formula is, if you can factorize the denominator, let's suppose you need to find the Euler's number of, let's suppose 10. Okay, you need to find the Euler's number of 10. First you factorize it, 2 into 5. Then 2 and 5 are the factors. 1 power is not important here. What are the factors is what important for us. Okay, so 2 and 5 are the factors. Then the formula is Euler's number n, En I can write it as n into 1 minus 1 by a into 1 minus 1 by b. What are this a and b? A and b are the factors. This 2 and this 5. What is this n? That is a given 10. So let's find it out. 10 into 1 minus 1 by 2. 1 minus 1 by 2 into 1 minus 1 by 5. So basically 10 into 1 minus 1 by 2 is 1 by 2. 1 minus 1 by 5 is 4 by 5, right? So this is going to be 10. So you get 4. So Euler's number of 10 is 4. What does that mean? Number of numbers which are co-prime with 10 less than 10. That means I need to see the non-multiples of 2 and 5. They are the prime factors. So what are the numbers? 110, 210 not possible because 2 and 10 are co-primes. 310, 410 is not possible because multiples. 510 not possible, 610 not possible. Then 710, 810 is not possible, 910. So these are the 4 numbers which are co-prime with 10, which is less than 10. More than 10 I can get many. And this is what you mean by 4. Euler's number of 4. What we did, you need to remember this only. Euler's number, if you need to find, n into 1 minus 1 by a into 1 minus 1 by b. A and b are factors. So if a, b, c are there, for example, 30 is their denominator. 2 into 3 into 5. Right? So then n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c. That means n is 30 here into 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. So 30 into 1 minus 1 by 2 is 1 by 2. 1 minus 1 by 3 is 2 by 3. 1 minus 1 by 5 is 4 by 5. Right? So this 30 is getting cancelled. You get 8. 8 numbers are there which are co-prime with 30 less than 30. I hope this is clear. Now, one interesting thing I tell you, if you need to find the Euler's number of a prime number, let's find it out. 7. Okay. So, what are the factors only? 2 factors, 1 and 7, right? So, 1 into 7. That means n into 1 minus 1 by a only. Only one factor, right? So, if 2 factors are there, n into 1 minus 1 by a into 1 minus 1 by b. 3 are there, n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c. Here it is only 1. So n into 1 minus 1 by a. That means 7 into 1 minus 1 by 7. This is what I have done earlier. So 7 into 6 by 7. This is getting cancelled. You will get 6. Okay. See. Now if you see, this part will be the number. This is the denominator. This always will be same. Now let's take 5. Another prime number. So 5. If Euler's number of 5 means n is 5 into 1 minus 1 by 5. What will be 5 into 4 by 5. This 5 is getting cancelled, you will get 4. If you find 11, E11, 11 into 1 minus 1 by 11, right? So 11 into 10 by 11, because 1 minus 1 by 11 and this is getting cancelled, 10. So what pattern you can observe? The Euler's number of the prime number will be 1 less than that of the number. And in most of the cases, you will get denominator as prime number. Okay, in most of the cases, you get denominator as prime number. If it is composite number, you have a better method. We'll use a better method. Even if you get 30 and all, still you can solve it by using this if 30 and the numerator are co-primes. But still, mostly you will get prime numbers. So if it is prime number, 1 less than that of the number. You don't want to do all these things. So if I give you a question like this, let's make a question. Let's fix the denominator 11. Okay, let's fix the denominator 11. So now how will you make question? Okay, so I know the Euler's number of prime number will be 1 less than that of the number. And I know if the power is Euler's number, let's suppose, right, let's fix the power also. Now, we fix the denominator and the power. Numerator I can write anything, which is co-prime with 11, less than 11 and more than 11. I can even write 13. I can write 9, I can write 7, I can write 5 or anything. Okay, I know this will give me what? Remainder 1. Now to make a question, I can simply change this 10 as, let me change it like this, 103. Simple change, 103. Now asking you to find the remainder. It's a tough question. But how will you solve? You understood what? Now you can solve easily because you only made the question, right? How will you solve? 13 raised to 10 by 11 is equal to 1. Remainder is 1. That means 13 raised to 10 whole raised to 10 will also give you remainder 1. Why? Because 100 is covered, right? 13 raised to 10 by 11, 10 such groups are there. All will give you 1. So 1 is the remainder. How much is left out? 13 raised to 3. Okay. So that you will write as into 13 raised to 3 by 11. 13 raised to 3 by 11. That you need to find manually. So you can write it as, how will you write this? 13 into 13 into 13. If you want, you can write like that. Divide by 11. Then you find the individual reminders. 13 by 11 remainder is 2 into 2 into 2. What is that? 8. So what is your answer? 8. That's it. That's how you make the question. Forget about solving questions which you get from the textbook. You can make questions like this. Now you can't forget it, right? Because you made the question. So let's make one more question. Okay, let's fix the denominator. Let's fix it as 17. Okay, or if you want, you can take a smaller number. Now 17 is a prime number. Okay, so Euler's number will be 1 less than that of the number. What is our rule? X raised to e by n. E should be the Euler's number of this. Then remainder will be 1. These two are coprimes. Okay, no condition between them other than they should be coprimes. So let's fix the power 16. Now, which number I can write here? You have no restrictions. You can write any number which is coprime with 17. Okay, you can write 1 here, you can write 2 here, you can write 3 here, you can write 4 here, you can write 5 here, you can write 6 here, you can write 7 here, you can write 8 here, you can write 9 here, you can write 10 here. Any number if you write, you will get remainder 1, because all these are coprimes with 17. Why all are coprime with 17? Because 17 is a prime number. So there is no multiples. I hope you understood. So you can define a prime number like this. This is a reverse definition. How will you define? If all the numbers less than a number, let's take here it is 17. If all the numbers less than that number are coprime with that number, then it's a prime number. That is the definition for prime number. If you want to make it a complex definition, right? Otherwise you know the definition. So in all these cases you will get remainder 1. So you take any one of this. Let's take 7 by 7. You can take any one. You can take above 17 also. Unlimited numbers. Okay. So I am taking 7. Or if you want you can take 8. Let me fix 8. Okay. Then power is 16 here. Let's change it to any power. Let's change it to any power. If you want you write it as 1617. Okay. Or if you want you write it as 162 or 163. Or let's take that 1617 itself. Not a problem for me. So how will you solve it? How will you factorize? See the denominator. Denominator is 17. Euler's number is 16. So you have to write this as 8 raised to 16 by 17. This will give you remainder 1. So you have to make a group of 100 or 101. Because 100 will give you 1600. 101 will give you 1616. Then one more left out. Okay, then it is very simple. You will just write 8 raised to 1 by 17. So this will give you remainder 1 and your answer is 8. 8 by 17, 8 is your answer. So I hope you understood how we make a question. And this is a difficult question. Now instead of 8, you take 7. Now the beauty is you can make question with any of this. So if it is 7, this much will give you same and this will be 7 by 17. That's the only change. That's the only change. If this is 7, because everything depend on denominator, right? And Euler's number of denominator. So this is have no role. Only in the end it is having role. Okay. Now how will you find it faster? I give you one more method. Let's take a question. Okay. Now let's take a question from the previous paper. Let's take this question 11 raised to 97 divided by 7. What is the remainder? Okay. We know the Fermat theorem. What is that? X raised to e divided by n will give you remainder 1. What is the condition? These two are, e is the Euler's number of n and these two are coprimes. Here if you see these are coprimes. Okay. Now basically what I need to do is, I need to write 97. I need to split in such a way that you should get remainder 1. Like what is the Euler's number of 7? 6. So if I write 11 raised to 6 by 7, I get remainder 1. So how many such groups I can make? 11 raised to 6 raised to 16, that is 96. No, yeah, that is 96. This will give you remainder 1. Then one group which is left out is 11, right, by 7. What is your answer? 4 is your answer. Now otherwise how will you solve this question? Now this is the final method. Okay, what I am going to tell you now is the final method, and this is the method that you are going to use in exam. Till now I was discussing the concept. Now let's take the question 11 raised to 97 divided by 7. You need to find the remainder. So what you need to do is, you know the Euler's number of 7 is 6. So you need to write the numerator as 6k plus some number. Then this will become 1. and your actual remainder will depends on this. Okay, so how will you do that? What you need to do is take out the power, okay, 97, divide it with the Euler's number of 7, that is 6. So you will get 1, okay, and we are going to use this one to solve the question. Okay, so you can do this question in 2 steps. Step 1, take these two numbers, 11 by 7, write the remainder. What is that? 4. Okay, then take that is the first step. That is the first step. Second step, take the power of numerator, 97. Divide the power of numerator with the Euler's number of denominator. Reason you know, we have discussed the logic, concept, everything. So 96, see what is the remainder. You get remainder 1. Now your answer will be 4 raised to 1. Your answer will be 4 raised to 1. Why? Because it is like you will write this as 11 raised to 96 by 7 into 11 raised to 1 by 7. Okay, now why this 1? That is because here it is 1. Why this 4? Because this is 4. What if it was 98? This become 2. So this become 2. So this will also become 2. Now 11 by 7 2 times. 11 by 7 into 11 by 7. So that's why 4 raised to 2. Now this is applicable in all the cases and all the questions. Let it be any question, you can just solve by using this concept. 2 steps. What is the first step? Divide the numerator without power with the denominator, see what is the remainder. Then divide the power of numerator with the Euler's number of denominator, see what is the remainder. Then write it. That's the 2 steps, you get the answer. Let me give you another question. 5 by 7 or 5 and 7 are coprimes. Okay, so let me write any power. You write 37. Okay, or if you want you write 38. So 2 steps. What are the 2 steps? 5 by 7, what is the remainder? 5 by 7, 5. Step 2, this is the first step. Step 2, 38 by Euler's number of 7, that is 6. What is the remainder? 2. So you can write 5 raised to 2, that is 25, which is greater than the divisor. So divide by divisor again, you get remainder 4. Or when you write 5 by 7 remainder 5, you can write it as minus 2. Instead of writing 5, you can write as minus 2. Then it become minus 2 raised to this 2, right? That will also give you 4. Just to make calculation easier so that you don't want to do this step. I hope you understood this. So what about 9 raised to 83 divided by 11? What we need to see, these two are coprimes. This is prime number. So what is the Euler's number of prime number? 1 less than that of the number. So you know 9 raised to 10 by 11 will give you remainder 1. So 9 raised to 80 by 11 will also give you remainder 1. So this question you can actually convert to 9 raised to 3 by 11. What is the remainder? Right? So then what is your answer? 9 into 9 by 11. So you can do this minus 2. You do this minus 2. You do this minus 2. So minus 2 raised to 3 means minus 8. Can remainder be negative? So add denominator. You get 3 as the answer. Or in 2 steps how will you solve? First is 9 by 11. What is the remainder? You can either write 9 or you can write minus 2. Second step, divide the power 83 with the Euler's number of denominator. So 83 by 10, you get 3. So your answer is either 9 raised to 3 or minus 2 raised to 3. Which one is better? Minus 2 raised to 3 is obviously better, minus 8. Since negative, add quotient, you get 3 as your answer. Or you will get 729 here. You need to again divide with 11. And that is now let's suppose you have a question. I have a number n is equal to 55555 raised to 6789. Okay, that's a big number, huge number. So let me make a story. Okay, that's how you can make question. Let me make a story out of it. You have a number which can't be even written in this in the board also. It is very difficult to write, right? So you don't know what is this number in fact. But if you know this number, you are adding the digits, sum of digits, like what we do in case of divisibility of 3 and 9, etc. You add the sum of digits, you get another number A. What is that? Sum of digits of n. Now, you got a sum, right? Then what is B is sum of digits of A. That means the previous sum. What is C is sum of digits of B. Like this you continue till you get a single digit. Okay, till you get a single digit. What is that single digit? I hope you understood the question. Or finally you got a number X. That is a single digit. What is that X value? Can you find it? I hope you understood, right? You have a bigger number, you take sum of digit, you take sum of digit. You remember in case of divisibility of 9, we have taken sum of digits of 1, 2, 3, 4, 5, 6 up to 50 or something. I think I have discussed this, right? So the same is the logic that you need to apply here. The question is actually based on divisibility of 9. What is divisibility rule of 9? You take sum of digits, sum of digits, sum of digits till you get a single digit, and the single digit that you are getting, if it is 0, that number is divisible by 9. If it is any other digit, that is the remainder when the bigger number divided by 9. So effectively single digit means this number, if you divide by 9, what is the remainder will be a single digit. I hope you understood. So I can actually write this question in this way: 5, 5, 5, 5, 5, right? 5 times 5 raised to 6, 7, 8, 9, divide by 9, what is the remainder? I hope all of you understood, because we have already done this discussion, divisibility of 9. What is that? Sum of digits till you get a single digit. Here also you are doing the same thing. So let's change the question like this. Now can you find it? See, now you can apply the concept that we have studied just now to find remainder, right? These two are coprimes. Why these two are coprimes? Because when you find the sum of digits, that's not a multiple of 3, right? Because 5 times means 25. 25 is not a multiple of 3, so these two are coprimes. So you can, now, what is the Euler's number of 9? How will you factorize 9? 9 is equal to 3 square. So E9 is equal to n into 1 minus 1 by a. 9 into 1 minus 1 by 3. Only one time, power is not important. So 9 into 2 by 3. So you get 6, and that's what we actually got earlier also. So what does that mean? If this was 5, 5, 5, 5, 5 raised to 6 by 9, your remainder will be 1. Okay. So now all these things are not required. Now you have the two-step process to get the answer, right? First you see what is the remainder when you divide this with 9. So first is 5, 5, 5, 5, 5 divide by 9. What is the remainder? You don't want to manually do. Just take sum of digits till you get a single digit. So 5 times 5, 25. 2 plus 5, 7. So remainder will be 7. Then what you need to do? Power of numerator you divide with the Euler's number of denominator. So 6, 7, 8, 9 by 6. Here also you can use the divisibility rule to find the remainder. Just take sum of digits. 6, 7, 13. 13 plus 8, 21. 21 plus 9, 30. 30 means it's a multiple of 3. But since it's an odd number, it's not a multiple of 6. So what will be the remainder? If you add another 3, you get a multiple of 6. Or if you subtract 3, you get a multiple of 6. So what is the remainder? Remainder is 3. So what is your answer? 7 raised to 3. Now 7 raised to 3 is obviously greater than 9, so you need to divide, right? Or instead of 7 you can also write it as minus 2, because this is 9. So if it is minus 2, you can write it as minus 2 raised to 3, which is equal to minus 8. Which is equal to minus 8, right? Minus 8 means how will you convert? You add 9, you get 1 as the remainder. Otherwise, how will you solve with this? 7 cube is 343. You need to know that. 49 into 7, 343, right? So 343, then it's a greater than 9, so you need to divide by 9 again. So you can find the remainder just by taking sum of digits. 3 plus 4, 7. 7 plus 3, 10. 10 means 1. Just take sum of digits. But you need to know 7 cube, 343. Then you can just take sum of digits. Otherwise, it is basically easy to take minus 2. Minus 2 raised to 3. I hope this is clear for you. So let me summarize what we have learned. We have learned Fermat theorem. You have a number. Okay. You have another number. Let's take n1 and n2. And you have a power as e. E is Ulas number of n2. Then the remainder will be 1. And we are actually using this thing to solve questions. So how will you make a question? Just fix the denominator 11. What is the Euler's number of 11? 10. Now here which numbers I can take to make a question? I can take any number, I'll get remainder 1. But only one condition, that number should be coprime with 11. So I can take any number less than 11 or some numbers which is greater than 11 also. So any number less than 11 will be coprime with 11 because 11 is a prime number. I can't take any number greater than 11. I can take greater than 11 only non-multiples of 11. I can't take 22. I can't take 33 like that. Otherwise I can take all numbers. If I take 21, okay, perfect. If I take 23, okay, perfect. I get remainder 1. Then how will I make a question? I make this 10 as 107 or 127 or 123, 143, whatever it is. Then you need to arrange in that way, right? If this is the case, what is your answer? The way you solve it is 23 by 11. You write it as 10, you get remainder 1. So 10 such groups are there into 23 raised to 7 by 11. So that you need to do manually. So I hope all of you understood this. If you have any doubt, you can comment and I'll play to it. Okay. So we'll stop here.